Okay, so we're going to look at another acid reaction. Again, we're going to use HCl, but this time we're going to use something that reacts with HCl, which isn't an alkali. It's calcium carbonate. Now, we've used this before when we looked at the rate. It's marble chips, and it's used to determine rate of reaction with surface area and concentration and things. But what we can see is this is now different to the previous examples that we've looked at of an alkali reaction. HCl is an aqueous solution, but calcium carbonate is a solid. And calcium carbonate doesn't dissolve in water. And so we don't call this an alkali. HCl is an acid, as we've already established. Calcium carbonate is a base. And this is where we need to really tighten up the definition of what an acid is. An acid is a proton donor, and a proton donor will react with a base, which is a proton acceptor. So we have a base being a proton acceptor, and that is what allows us to work out what's going on. So the hydrogen is being donated from the HCl, then that hydrogen is being donated to the base in some way. And a base is a proton acceptor. Now, all of the previous examples that we've looked at, so for example, sodium hydroxide, or we looked at lithium hydroxide, we called all of these alkalis. And the differentiation here is that these substances dissolved in water. And so they are basic in the sense that these will also accept a proton. Therefore, they're basic in that chemical situation whereby they will accept a proton, they will accept a hydrogen ion. But because they dissolve in water to form a solution, we call them an alkali. If the substance that is reacting with the acid accepts a proton but has done so by not dissolving in water, then we would call that a base. Now, overall, an acid plus a base reaction is the same as an acid-alkali reaction, or an acid-alkali reaction is the same as an acid-base reaction. It's probably more correctly worded, in that an acid plus a base will still give a salt plus water. So we can see from this substance here that we've got hydrochloric acid. So we know we're going to produce a chloride of some sort because of the type of salt we're going to produce. We know we're probably going to get a calcium salt. So we know that the salt is going to be calcium chloride. And we're also going to produce water because we always produce water in an acid-base or acid-alkali reaction. So water is always produced. However, the extra proviso here, which is a curiosity of the carbonates, which are used as a base, is that they will also produce carbon dioxide. So when you get these reactions, you get an acid plus a base giving the salt plus water, which is correct in the usual sense, but as an extra byproduct, whenever that base is a carbonate, we will also produce carbon dioxide as a byproduct. However, the same ideas of salt preparation and water production is the same because the acid has donated its hydrogen ion to the base and allowed us to produce a salt and water. Calcium carbonate, obviously, it's got its more common name of limestone, and we'll look at that when we look at some more using of resources sections later.